Alright, so on this video I'm going to show you how to draw a Bohr model and also a Lewis electron dot structure. So we're going to do this for the element magnesium, and this is what you would see on the periodic table. You're going to be given the atomic number, the symbol, the atomic mass, and the name of that particular element, as you can see here. Okay, we realize that it's on period 3 and it happens to be on group 2. Okay, so some of the information we're going to gather is first its atomic number. So its atomic number is 12. It has a mass of 24.305. When you're doing subatomic particles, which are protons, electrons, and neutrons, you want to go ahead and round this number to a whole number. So we're just going to say that the atomic number is 24 because it's a lot closer to 24 than it would be to 25. If this would have been a 5, then we would have rounded up. Okay. If you notice on this paper, I went ahead and highlighted the A, the P, and the E. It spells out the acronym APE, okay? And the reason I did that is because I wanted you to realize that the atomic number, the number of protons, and the number of electrons are always going to be the same exact number. So if the atomic number is 12, then that's going to tell you that you've got 12 protons and 12 electrons. And the reason you're going to have the same number of protons and electrons is because you want an atom that's electrically neutral, so that it'll cancel out, because remember, protons are positively charged and electrons are negatively charged. For the neutrons, it's going to take a little bit of math, nothing very complicated. So this is where you take your atomic mass and you're going to subtract your atomic number from it. Okay, so once we do the math, we find out that it is 12. Okay, so we're going to go ahead and start by drawing the nucleus, which is the middle portion of an atom. So in our nucleus, we're going to have our protons and our neutrons. Okay, so that's my nucleus. Went ahead and did a little cloud structure so that it could be distinguished as the nucleus instead of when you see the circles, so you don't confuse them. Okay, so I'm going to put the symbols as well. So this is showing that it's protons, and this is showing that this number represents the neutrons. Okay, for us to find out how many orbitals or rings magnesium has, we're going to look onto our periodic table. Remember that the period is going to indicate how many orbitals or rings it has. So because it's on period 3, all of the elements in this period are going to have 3 rings. So we're going to go ahead and draw 3 rings around the nucleus. Okay, remembering back from our Nearpod notes, if you recall, period 3 elements, the first ring can hold 2, the second ring can hold 8, and the third ring, the last ring, can hold up to 8. Doesn't mean you have to have 8, but it means the last element on that period can hold up to that many. So here we go. We're going to go ahead and draw the ones in the inner circle. So it's got 2 electrons, and we're going to draw them in pairs, because for the most part they travel in pairs. Okay, so that's going to be your first 2 from ring 1. Just like we see here. Okay, on the second ring, it's going to be 8. And notice how I did it in a weird fashion. That's because I want you to go ahead and put them in a clockwise fashion and also keep them in pairs. Okay, the last ring. So we have 8 on the second, 2 on the first. That's 10. And remember that magnesium has, if we look, 12 electrons. So if we have 10 already, that means that we're missing 2. As you're getting ready to draw the electrons on the last ring, I want you to do them in the same fashion we did it on the second ring. So starting from the top, we're going to say that's your 11th electron, and then we're going to put the 12th electron here. And no, we're not going to put them in pairs, and you're going to see the why, because now I'm going to show you how to draw a Lewis electron dot structure. Now these electrons on the outside, on the last ring, they're called valence electrons. Those are the electrons that we use for bonding. Those are the ones that go with other elements and they bond and make compounds. Okay, so we treat them with respect, so to speak, in chemistry. Okay, so now to do the Lewis structure, what you do is you write the symbol of the element. So there it is, magnesium, and you're pretty much going to copy what you see here. So on the last ring, again, to do the Lewis electron dot structure, copy the electrons that you see on the last ring. So we have our valence electron here, and then our second one here. Which also reminds me to tell you that it so happens that that is also connected to the fact that it's in group 2. These elements that are in group 2 are all going to have 2 valence electrons. So if you can think that beryllium, magnesium, calcium, strontium, barium, radium, all these are going to have the same look on valence electrons because they're in the second group. This is going to happen the same for those that are in the first group. They'll have 1 valence electron, and the same thing, we're going to skip the transition elements, but for the representative elements, all these will have 3 valence electrons. These will have 4. Then this column 5 or group, this one 6, 7, and 8. Okay, and that's our little shortcut when we're trying to find valence electrons.